Hello students, in this session let us discuss about trigonometric equations. In the previous sessions you have studied about trigonometric functions. Now we will be discussing about trigonometric equations. First of all, what is an equation? Equation is a statement with equal to sign. Equal to sign ಇರುವಂತಹ ಸ್ಟೇಟ್ಮೆಂಟ್ಗಳನ್ನು ನಾವು equation ಅಂತ ಹೇಳ್ತೇವೆ. Now, if equation contains trigonometric functions, then it is called as trigonometric equation. Trigonometric equation andre equation containing trigonometric functions. Trigonometric functions iruvantaha equation galanna trigonometric equation anta helteve. For example, 2 sin x minus 1 is equal to 0. Sin x is the trigonometric function which is present in this equation. So, this equation is a trigonometric equation. Another example, sin x minus cos x is equal to 0, or 2 tan square x minus tan x plus 1 is equal to 0. These are examples for trigonometric equations. Now, whenever we have an equation, we would like to find the solution. Solution in the sense, the value of the variable satisfying the equation. For example, if we have an equation 2x minus 6 is equal to 0, then x is equal to 3 is the solution of this equation, because when we substitute x is equal to 3 in this equation is satisfied. 2 into 3, that is 6, minus 6, which is 0. LHS is equal to RHS. So, x is equal to 3 satisfies the equation. So, x is equal to 3 is the solution of the equation. Similarly, we would like to find the solution of a trigonometric equations. Let us take the first example, 2 sin x minus 1 is equal to 0. To find the solution, let us rewrite this 2 sin x minus 1 is equal to 0 as taking minus 1 to the right hand side. So, 2 sin x is equal to 1. Hence, sin x is 1 by 2. Sin of x is equal to half. Sin of what is half? We know that sin of 30 degree is half. Sin of 30 degree is half. But in this chapter, we have defined trigonometric functions in angles measured in radians. And therefore, we have to convert this 30 degree into radians, that is pi by 6. So, sin of pi by 6 is half, 1 by 2. So, in the place of x, if we substitute it as pi by 6, the equation is satisfied. Therefore, x is equal to pi by 6 is a solution of this trigonometric equation. Is this the only solution? No. We know that sine value is positive even in the second quadrant. Or if you remember the graph of sine function, at pi by 2 it is 1, at 0 it is 0, at pi sine is 0. Half in the sense exactly middle of 0 and 1. We know that at pi by 6 sine is half. Also we see that sine takes value half in between pi by 2 and pi, that is in the second quadrant. So, and there is an angle in the second quadrant such that sine of x is half. That angle is 5 pi by 6. I will tell you the method of finding this later on. If x is equal to 5 pi by 6, then sine of 5 pi by 6. 5 pi by 6 can be written as pi minus pi by 6, and sine of pi minus theta is sine theta. So, this will be sine of pi by 6, that is half. So, even when x is equal to 5 pi by 6, equation is satisfied. So, x is equal to 5 pi by 6 is also the solution of the trigonometric equation. Do we have some more solutions for this equation? Yes. We know that trigonometric functions repeats after one complete revolution. In fact, it repeats after every complete revolution. One complete revolution in the sense 2 pi. So, if the angle is 2 pi plus pi by 6, 2 pi in the sense one complete revolution, then sine of x, that is sine of 2 pi plus pi by 6 will be same as sine of pi by 6, that is half. So, when x is equal to 2 pi plus pi by 6, the equation is satisfied. So, x can be 2 pi plus pi by 6. It can be 2 pi plus 5 pi by 6, because sine of 2 pi plus 5 pi by 6 is the same as sine of 5 pi by 6, which is half. So, x can be 2 pi plus 5 pi by 6. We may consider two complete revolutions. In that case, we will have 4 pi plus pi by 6. Sine of 4 pi plus pi by 6 is half. So, x can be 4 pi plus pi by 6, or it can be 4 pi plus 5 pi by 6. Or we can consider 3 complete revolution and so on. Even we can consider the negative direction or clockwise direction. If I consider x is equal to minus 2 pi plus pi by 6, then sine x is half. Sine of minus 2 pi plus pi by 6 is equal to half. So, which means, this means there are infinitely many solutions for this trigonometric equations, and the solutions in between 0 and 2 pi radians, in between 0 degree and 360 degree is called as principal solutions. Here x is equal to pi by 6 and 5 pi by 6 are principal solutions. So, principal solutions of a trigonometric equations are the solutions in between 0 and 2 pi radians. Also, we can write an expression involving arbitrary constants which will represent all other solutions of the trigonometric equation, which is called as general solution. General solution. General solution is an expression involving integer n which will represent all the solutions of the trigonometric equations, which will satisfy the trigonometric equations. So, principal solutions are solutions in between 0 and 2 pi radians. For an equation, we will have two principal solutions, and general solution is an expression involving an arbitrary integer n which will represent all the solutions of the trigonometric equations. For example, let us consider an equation sin x is equal to 0. Sin x is equal to 0, you have studied that this implies x is equal to n pi, where n is an integer. So, here if we give different values for n, we will get the different value of x satisfying this equation. This is an expression involving an integer n and which will represent all the solutions of this trigonometric equation. So, x is equal to n pi is the general solution of sin x is equal to 0. If I substitute n is equal to 0 or n is equal to 1, then x is equal to 0 into pi, that is 0, and x is equal to 1 into pi, that is the pi. X is equal to 0 and x is equal to pi. These two are angles in between 0 and 2 pi radians, and therefore these two are principal solutions of sin x is equal to 0. X is equal to n pi, where n is an integer, is the general solution of sin x is equal to 0, and its principal solutions are 0 and pi radians. Now let us write a note which will simplify our work in finding the principal solution of a trigonometric equation. If the angle lies in the first quadrant, let us take it as angle A. If angle lies in the second quadrant, we will take it as pi minus A. If it lies in the third quadrant, we will take it as pi plus A. And if it is in fourth quadrant, we will take it as 2 pi minus A, where this A is an acute angle. A is an acute angle. Let me explain it with an example. Before that, here x is equal to 5 pi by 6. We can recognize this solution using this note. Because sin is positive in first and second quadrants, the angles are A and pi minus A. We can find the acute angle, that is x is equal to pi by 6, we can easily recognize. To find the other solution, we use this note. As it is in the second quadrant, it will be pi minus A. A is the acute angle. Here the acute angle is pi by 6. So, this will be pi minus pi by 6, which is 6 pi minus pi by 6, or is 5 pi by 6. This is how we can find the second principal solution of the trigonometric equations. Let us solve some more examples. Let us try to find the principal solutions of tan x is equal to root 3. Now, tan x is equal to root 3, tan x is positive. In which two quadrants tan is positive? We know that in the first quadrant all trigonometric functions are positive. In the second quadrant sine and its reciprocal are positive. In the third quadrant tan and its reciprocal are positive. And in the fourth quadrant cos and its reciprocal are positive. Now, tan function, tan is positive in the first and third quadrants. In the first quadrant, we will be taking it as angle A. In the third quadrant, it will be pi plus A. Now, what is A? A is the acute angle satisfying the equation. Tan x is equal to root 3. Now, tan of what is root 3? If you consider the table, tan 0 is 0, tan 30 degree is 1 by root 3, tan 45 is 1, tan 60 is root 3, tan 90 is not defined. 30 degree in the sense pi by 6, 45 degree is pi by 4, 60 degree is pi by 3, 90 degree is pi by 2 radians. Now, tan of 60 degree is root 3, or tan of pi by 3 is root 3. So, one solution is pi by 3, or the angle A is pi by 3. Now since tan is positive in the first and third quadrant, the principal solutions are A and pi plus A. So pi by 3 and pi plus pi by 3. Pi plus pi by 3 we need to simplify. It is 3 pi plus pi. So 4 pi by 3. So the principal solutions are pi by 3 and 4 pi by 3. Next example, secant x is equal to 2. It would be easier if the trigonometric functions in the trigonometric equation is sine, cos or tan. So let us try to write secant x in terms of cos. We know that secant is reciprocal of cos. So let me take the reciprocal of this equation. So it will be 1 by secant x is equal to 1 by 2, and 1 by secant x is cos x. So cos x is equal to half. Cos x is equal to half is the equation. Now we would like to find the principal solutions of this equations. First of all, cos is positive. In which two quadrants cos is positive? In first and in the fourth quadrant. So it is the acute angle and 2 pi minus the acute angle. Which is the acute angle here? Cos x is equal to half. Cos 0 is 1, cos 30 degree or cos of pi by 6 is root 3 by 2, cos of 45 is 1 by root 2, cos of 60 degree is half, and cos 90 is 0. So cos of 60 degree is half, or cos of pi by 3 is half. So the acute angle is pi by 3. So the principal solutions are pi by 3, and in the fourth quadrant it is 2 pi minus a. So it is 2 pi minus pi by 3, which is 6 pi minus pi by 3, or as 5 pi by 3. So the principal solutions of secant x is equal to 2 are pi by 3 and 5 pi by 3. Next example, sin x is equal to minus root 3 divided by 2. Let us try to find the principal solutions of this equation. Here we see that sine is negative. Sine is positive in first and second quadrants. Here sine value is negative, so the angles lie in third and fourth quadrants. In the third quadrant, we will be taking it as a pi plus a. In the fourth quadrant, it is 2 pi minus a. What is A? A is the acute angle. So here, acute angle, to get the acute angle, we will take the positive value of trigonometric function. Sin x is equal to plus root 3 by 2. If sin x is equal to plus root 3 by 2, then what is x? We know that sin 0 is 0, sin of 30 degree is half, sin of 45 degree is 1 by root 2, sin of 60 degree is root 3 by 2, and sin of 90 degree is 1. So sin x is root 3 by 2 when x is pi by 3 or is 60 degree. So here the acute angle is pi by 3. So what are the principal solution? The principal solutions are pi plus a and 2 pi minus a. Pi plus a. A is the acute angle. Here it is pi by 3 and 2 pi minus a. A is pi by 3. So, this is 3 pi plus pi by 3 and 6 pi minus pi by 3. That is 4 pi by 3 and 5 pi by 3. So, the principal solutions of sin x is equal to minus root 3 by 2 are 4 pi by 3 and 5 pi by 3. Next example, cosec x is equal to minus 2. Cosec function, so first we shall write it in terms of sine function. Cosec x is equal to minus 2, so it is a reciprocal, that is sin x will be reciprocal of minus 2, that is 1 by 2. Now, sine is negative. Sine is negative in third and fourth quadrants. So, we will have the principal solutions as pi plus a and 2 pi minus a, where a is the acute angle. So, to get the acute angle, we will take sin x as plus half. Sine of what is half? Sine of pi by 6 is half. So, the acute angle is pi by 6. Therefore, the principal solutions are third and fourth quadrant. So, pi plus a is pi by 6 and 2 pi minus a is pi by 6. So, it is 6 pi plus pi, that is 7 pi by 6 and 6 into 2, 12 pi minus pi, that is 11 pi by 6. So, principal solutions are 7 pi by 6 and 11 pi by 6. Next example, cot x is equal to minus root 3. First, let us write cot in terms of the first three trigonometric functions, sine, cos or tan. We know that cot function is reciprocal of tan. So, we can write cot x as cot x is equal to minus root 3 as tan x is equal to minus 1 by root 3. Now, to find the principal solutions, first we see that tan is negative. Tan is positive in first and third quadrants. So, in the other two quadrants tan is negative. So, tan is negative in second quadrant and in fourth quadrants. In the second quadrants we calculate the angle as pi minus a, and in the fourth quadrant we will be taking it as 2 pi minus a. Also we need to find the angle A, the acute angle A. To find the acute angle A, we will be taking the positive value of the trigonometric function. So, we will be taking it as plus 1 by root 3. So, what is x then? Tan of pi by 6 is 1 by root 3. So, angle is pi by 6. The acute angle is pi by 6. Therefore, the principal solutions are in the second and fourth quadrant. So, they are pi minus the acute angle pi by 6 and 2 pi minus a, 2 pi minus pi by 6. Simplify these two angles. It is 6 pi minus pi by 6, and here it is 12 pi minus pi by 6. That is 5 pi by 6 and 11 pi by 6. These two are principal solutions of tan x is equal to minus 1 by root 3 or of cot x is equal to minus root 3. Next example, secant x is equal to minus 2 by root 3. First of all, we write secant x as its reciprocal, that is cos function. So, cos x is reciprocal of minus 2 by root 3 will be root 3 by 2. Cos x is equal to minus root 3 by 2. So, here cos x is negative. Cos value, cos function is positive in first and in fourth quadrant. So, in the other two quadrants cos is negative. So, cos is negative in second quadrant and in third quadrant. So, the angles are pi minus a and pi plus a. A is the acute angle. So, here we have to find the acute angle. To find the acute angle, we will take the positive value of cos x, that is we will take it as cos x is equal to root 3 by 2. Cos of which angle is root 3 by 2? Cos of pi by 6 is root 3 by 2. So, angle A, the acute angle is pi by 6. Now, since cos is negative, cos angles lie in second or in third quadrants. So, the principal solutions are they are pi minus the acute angle, which is pi by 6, and pi plus acute angle, pi plus pi by 6. Simplify, this is 6 pi minus pi by 6. Here it is 6 pi plus pi by 6. So, we have 5 pi by 6 and 7 pi by 6. So, the principal solutions are 5 pi by 6 and 7 pi by 6. Next example, sin x is equal to minus 1. Sin is minus 1, sin x is a negative. Where in which two quadrants sin is negative? In third and fourth. In first and second quadrants sin is positive. So, in third and fourth quadrant sin is negative. So, here x lies in third or in fourth quadrant. In third quadrant we will take it as pi plus the acute angle. In fourth quadrant we are taking it as 2 pi minus the acute angle. What is the acute angle here? Sin x, let us take it as plus 1. So, sin x is equal to 1. Then what is x? Sin of 90 degree is 1 or sin of pi by 2 is 1. So, the angle is pi by 2, the quadrant angle. So, what are the solutions? The principal solutions angles lie in third and fourth quadrant. So, it is pi plus pi by 2 and 2 pi minus pi by 2. Simplify this, 2 pi plus pi divided by 2 and 4 pi minus pi divided by 2, that is 3 pi by 2 and 3 pi by 2. That is 3 pi by 2 is the principal solution. So this is how we find the principal solutions of a trigonometric equation.